my paper is about sensors, biosensors and machine sensors in reality, and how a sensor, what is the role of a sensor, not one particular sensor, but when installed to a certain number of sensors in a machine, that can be equally compared or considered to the same level of biosensing that all humans have. Biosensor here is, for instance, the 5 senses that we all know about it: vision, taste, hearing, smell, and touch. But there are others. For instance, the sensing ability of temperature, the sensing ability of pressure, the wind in our faces, in our body, the sensing ability of magnetic fields around us, with many have more conscious, in a more conscious way, and others in a more unconscious way. The sensing ability of electric fields, for instance, feeling an electric shock. The sensing ability of any kind of radiation, radio radiation, for instance, on antennas, transmitting data or transmitting some kind of electric field, electromagnetic field. The sensing ability of joining all those senses into something, into a new sense, a mix of senses, for instance. And I can continue with many other sensors, biosensors that human biology has. Not only human biology, but nature itself has constantly working and sensing the environment at every moment, every passing moment, every second, every millisecond that is happening in the present now. And how those biosensors translate into into the machine world, and how can that be equally compared to humans, to human intelligence. So in a machine world, there's also sensors. For instance, a camera on a smartphone is a sensor, is a vision sensor. It's a more rudimentary vision sensor that we humans have. It's a 2D vision sensor. It doesn't have the ability to perceive depth. It only perceives image as if it were in a frame, in a 2D frame, in a two-dimensional frame. There's also microphones that have the ability to hear in all ranges of frequencies beyond the human capabilities of the hearing, of a human hearing. There's also temperature sensors, there's pressure sensors, there's light sensors. Nowadays there are all kinds of sensors too. And when considering installing the same number of sensors and the same type of sensors into a machine, how does that affect and mold the artificial intelligence that is running on that machine? One well-known example on the internet is that robotic arm on a factory that has the sensing ability to perceive the factory worker that is working side by side with that robotic arm. When is in the line of sight of the next move that the robotic arm is about to do, it waits for the worker to move to a safer place, and only then it resumes the movement that is in the queue to be made. That is a great example, but is also an example that shows how limited the sensing abilities of machines are nowadays. In that particular case, the machine is only able to sense to some degree, to some resolution, if you like it in those terms, that something, it doesn't even know what it is, but something is in the line of sight and keeps it from doing the next operation correctly. And that robot arm only knows that something doesn't know what, doesn't need to know, but something is in that line of sight and is unable to continue what is cued to do. Now, getting back to the initial question, but what happens when a machine has the same number of sensors, the same number and the same type of sensors as we humans do? What kind of intelligence will be? And my best answer, at least in this first half of 2022, is that intelligence only can be a super intelligence, but not that super intelligence that is feared. It's a super intelligence that is in the dreams of all of us, that is in the presentations and public speakings about the better human that we all need to be every day. Why? Because that machine is able to understand and perceive reality in a degree that we humans, most of the times, decide to put aside. I'm not saying ignore, but put aside on a shadow, a personal shadow, because we have more urgent, more priority tasks to do on a particular moment. We have to work, we have to pay our bills, we have to pick up the kids, we have to go do some shopping, groceries. And so the other tasks, the other simple tasks, the other gratuitous tasks, cost-free tasks, are lowered in that queue to a low priority, and many or most of the times it's not even put on a queue. It's just simply dismissed and life goes on. Lowered in that queue to a low priority, and many or most of the times it's not even put on a queue. It's just simply dismissed and life goes on. This is how I see this thing in biosensors and machine sensors, and how it will change artificial intelligence that can be considered equal or at least comparable to human intelligence. Of course, there are other kinds of artificial intelligence, but in that sense, I don't think it's the terminology needs to be changed and reviewed again, because it will no longer be artificial and it will be no longer intelligence. It's just data processing by computer algorithms that do perform extremely well and extremely fast, and faster than we humans do, and just because of that provide us with all the good things that we are now starting to have access to. For instance, movie recommendations, just in a click of a button. For instance, draw a plot of events expected to happen if we continue with our current plan that we have inputted, and things like that. And to me, it's not. I don't consider that to be intelligent. It's just mathematics. Can be any kind of mathematics. It can be linear, non-linear, numerical, probabilistic, or quantum mathematics. It doesn't matter. It's just, it continues to be mathematics running on super fast computers at super fast speeds, at light speeds actually. And because of that, it will fascinate us. It is fascinating us with how fast the results are achieved using those computers, those fast computers and algorithms. And it's just that. It's just because it's fast and we are too slow and nothing more. But I don't consider that to be intelligent, as at least as defined as in human terms of intelligent and intelligence.